what do I know about tangent? Tangent has two asymptotes. It has a midline, and typically there's a center on those two asymptotes. And if it's a positive tangent like this one is, what do we say about positive tangent? Does it, from left to right, does it fall or does it rise? Anybody remember? Yeah, one person said rises. Okay, the rest of you, can you at least back your notes up and cheat? And if you don't have an answer, couldn't you have just gone back to look at a basic picture? This one was of a cotangent. And a cotangent looks like it falls. Go back to the tangent, let's see. And Moises, you said rises, right? Rises gets the extra credit. Okay, so let me make a note to myself. Moises went out of his way to realize that it goes up, comes through, and rises from left to right. So if it was a negative tangent, though, it would have a negative. This is a positive tangent. A negative tangent would have been the other way around. Look like that. Which looks a lot like cotangent, except the cotangent is not at the midpoint is not at 0. It's shifted to the right, if you recall. Let me look at it. Cotangent. Cotangent, here's 0. Here's pi. So pi over 2 is where the middle was of cotangent. Cotangent looks like a negative tangent, but it's not because it's shifted. Okay? Just like sine and cosine, how they were different by a shift, remember? All right, what am I going to do here? Now, these steps are actually good. I really underestimated how valuable they really are. I'll just point out a couple things that I do. Your period will always be a pi divided by b. Not 2 pi. Here's the reason. Look back at the pictures. Even in the cotangent. Let me go back to a nicer picture because, well, actually, this is a tangent. Notice it went from a negative pi over 2 to pi over 2. That's a distance of pi. So a regular tangent finishes the whole picture in pi. Not 2 pi like sine and cosine does. Same thing for cotangent. From asymptote to asymptote is still a distance of pi. 0 to pi is pi. So that's important. Now, once you do that, you have to realize that's the whole distance between, I'm doing a little more detail than I did yesterday because I think they may have got lost. This whole distance is pi. So wherever that center is, you have to find the center, which is in the middle of pi. And in this case, well, not the middle of pi. In other words, whatever these asymptotes are, you have to cut it in half because that tells you how far you got to go to get to the asymptote. That's what he's doing right here. He's finding your asymptotes. But what else do I like? Okay, I do this. I do the vertical lines and talk about those vertical asymptotes. But he wants me, he does it by dividing it into 4 equal parts. And I got to thinking at home yesterday, that isn't a bad idea. Because what happens, look at my picture. I'm going up, going up. And I'm just saying it bends somewhere and then it goes through here, and then it has to go back up. But if you have 4 points, you would have this point and this point where the asymptotes are. Then you have another point and another point. You'd find these points here by dividing up into the 4 pieces. And that tells you exactly how it's going to curve. You could actually go curves down towards there, curves up through there. It makes it a better graph than what I usually do. So I was thinking at home, maybe I should have done a little more detail on that. All right, we're going to graph y equals tangent of bx. So the only transformation it has is It's not a phase shift. It doesn't move left or right. It doesn't move up or down. It changes your period. So if my B is a 2, I need to realize that my period will be pi divided by 2. That means it takes pi over 2, or I could call it 90 degrees, to complete a whole picture. So wherever the midpoint is, this whole distance is 90 degrees. And since tangent, if it isn't shifting left or right, starts right here. That's the center. So I got to go and make a asymptote this way and an asymptote this way. And then realizing that if this is 0 and this whole distance is pi, half of pi is pi over 2. So this distance from 0 to here is a pi over 2 distance. This distance from over here is a negative pi over 2 distance. And that gives you your pi over, what I say, pi over 2 is your period. Trying to figure if did I do that one right? Anybody have a comment to add? Because, oh, I got to write Mario down because Mario gets extra, right here, Mario. He gets points if he messages me later on today. No, I don't know you. Remember I called you Mario yesterday? What is this? I don't even have a Mario. Okay, so Moise, did you want to earn more points? Do you? Did I do anything wrong? I think I might have. I think I'm wrong. You sure? Anybody else want to catch me before I say it? Okay, going once, twice, gone. I said the period is pi over 2, not pi. I was thinking pi from if it was not a B is 2. This distance here has to be a pi distance. Not sorry, I said that's what I said a minute ago. It would be a pi if it did have a 2 in front. This distance is a pi over 2. So this can't be a negative pi over 2 and pi over 2. It has to be a pi over somebody. Quickly, you'll get a point. Nobody wants points. If this total distance is pi over 2, what does each of these pieces have to be? Because it's
pi
not
over 4.
Who said that?
Anne.
Anne, thank you very much. Anne gets it. Pi over 4. I was thinking of B being equal to 1, the normal tangent, like here. The normal tangent was negative pi over 2 to pi over 2. But because, think about it, if there's a 2 here, that means there's 2 whole pictures in the time it takes for pi to get done. If you go pi distance, you'll have 2 pictures worth. Because you get 2 tangents in a total of pi. 2 tangent graphs in the distance of pi. So pi over 2 is how long it takes for, or half a pi is how long it takes for 1 picture. So here's 1 picture. So now, normally I get lazy. And I'm going to erase, don't copy this just yet. I should be lazy. Normally what I do is just say to the kids, okay, we know it goes up here, it has to come out, it has to go asymptotic. We know it comes out here and eventually it has to start going down. And I'm lazy. You know, I just draw that and say, okay, I'm happy. Okay. But in reality, I like what our textbook did, and I should have just done it, is instead of dividing it into 2 pieces, divide it into 4 pieces. That way you'll have another good point on the graph. So what's in the middle of 0 and pi over 4? Anybody? Oh, 0 and pi over 4. What's in the middle? I gave you guys a good shortcut. 0 plus pi over 4 divided by 2.
Pi over 8.
Is that you again, Ann?
Yes.
Pi over 8. If I go up, make a dot, and that's where I want you to curve that point up to. That way, I should have done that yesterday too. What would the other side be, Ann?
Negative pi over 8.
So there's a point here, see, and I can come down, comes out, and actually I can make sure I go through that point before I start going down. It makes it a better graph. Now, this is only one period of a picture. Sometimes the book wants 2 periods. So what it does is it creates another asymptote. And what it does is it doesn't do the full picture over here. It doesn't do the full picture here. It cheats. And it only does on this side, I think it goes, well, in the middle there goes another point. So it does this, that picture. And then this side, he does the other side that goes up and over that way. I've seen a lot of textbooks give me that picture instead, because then that's a total of 2 pi, because that's a half and a half is another, not 2 pi. Well, actually is going to be, I think, half and a half adds up to another period. I should say 2 period, whatever the period is. Well, I guess it will be 2 pi. So our book, our PowerPoints, I think when I saw it, they just did the full picture out here again. And they just did the full picture out here again. I don't need you to label everything. I just need, give me 4 X's down here. I should tell that to 8A. Just give me 4 X's. Like these 2 asymptotes and 2 X values in the middle here. Oh, and the middle. I guess there's 1, 2, 3, 4, 5 X's I would want, just to make sure you understand what's going on. Again, this is not that important enough to kill yourself over it. All right, another one. This one's another tangent. And, normally tangent is between the 2 asymptotes. As I said, normally tangent, as Moises said, rises, right? That's what Moises said, it rises. But what happens if there's a negative in front? Somebody. Right, it falls. Moises wants another point. It falls now because it flips it. The negative in front of any function flips over the x-axis. So when this thing flips, then it comes, this piece is falling down now, and this piece is rising up now. Well, I'm sorry, I just already did it falling down. The normal tangent, yeah, falls down. There he goes. It's that color. I should do a different color. It did change color. That's what happens with a negative tangent. The 3 is a vertical stretch. You almost can't even tell, in my picture. How do you stretch something that is going towards an asymptote? How do you stretch it? If this is your asymptote and you decided to stretch it, usually that happens, then the point in the middle is probably higher. So when you stretch it, it's kind of more like skinnier. So it goes higher faster. That's what happens with that, but you won't even hardly tell. I don't even care about that, to be honest with you. I do care about B. B is a half. So my period is pi divided by a half. What is pi divided by a half? Anybody? Pi divided by a half.
2 pi.
It is 2 pi. Who was that?
Betul.
Who?
Betul.
Oh, Batul?
Yes.
Okay, you guys, if you don't message me though today, I will not remember. You got to message me about extra credit. She's absolutely right. It's 2 pi. So that means this whole distance has to be 2 pi. It isn't shifting left or right, so we're still at 0, 0. But if this is 2 pi, then half of 2 pi is pi. So this would be my positive pi, and this side would be a negative pi. Okay, you follow? So let's do it. Pi, negative pi. It didn't shift left or right, so it stays at the 0. And what did I ask you to do that I didn't do for A day? Go ahead and get me a middle x here. And that would be half of 0 to pi is pi over 2. Half of 0 to negative pi over 2. And really what you should do is plug those values into the equation to see what's happening. If y is equal to a negative 3 tangent of a half of the x. And take a second and ask yourself, if I plug in pi over 2 in place of this x right here, this one right here, plug that into here. It looks like this. It's like making a table. Here's your x's, what's your y? So negative 3, tangent of pi over 2 times pi over, or 1/2 times pi over 2. Wouldn't that be the same as negative 3 tangent of pi over 4? Yes, no? 1/2 times pi over 2 is pi over 4. That's a 45-degree angle. What's the tangent of 45? Real quick. Got to be fast, guys. That one you shouldn't have memorized. Nobody has it. Bummer. So 1. Remember the triangle? They're both 45 degrees. That's a 90. It's a 1, 1, square root of 2. Tangent is opposite over adjacent. It's 1. So over here, I'm going to go up 1. So I'll have to label the 1, and I'll go up to the 1. I'll actually, if I do the negative pi over 4, that is negative 1. So then I go down negative 1, put my dot. So if you do that, your picture will be better than my average picture, okay? I come up from the bottom. Oh, wait, it's flipping. Is it rising or is it falling, Moises? Oh, it is right. See, look where the points are. It's rising, right? So I come up from the asymptote here. That asymptote goes down here. I'm coming up, curve here, go up here, and then I don't know. I should have curved made a little more curve there, something like that. You're better than me. I'm sure you can get it better than me. And that's a pretty good picture. And I have already my numbers are there. Look at that number's there, that number's there, that number, I didn't write it, but it's understood. That number's there, that number's there. They're beautiful. I got my y value here. If you did all that, that's 100. You know, you got all that, even if you do it as sloppy as me. Doing one more. Okay, a cotangent. It's a positive cotangent. So what does it do? Does it rise or fall? If you forget, just scoot over and look at the cotangent picture. That was the tangent. It rose. Oh, cotangent, it fell. And it is not centered at 0, 0. 0, 0 was an asymptote, remember? Okay, yeah, I remember now. Nobody remembers all this forever. So that meant 0, since I didn't go left or right, is an asymptote. And then there's an asymptote over here. There's an asymptote over here. And I know that in between here is where my first picture is that I'll be drawing, okay? So let me figure out what's going on here. Oh, the 1/2 means it's going to be kind of like fat. It's going to be fat. If you did it on a calculator and you compared it to the regular, you'd see it got fatter, but I'm not going to play the game here. Their b is a 2. So my period is pi divided by 2. So this whole distance here has to be 90 degrees, pi over 2. And what's half of 90 degrees? Is that easier? What's half of 90?
40.
Say it again, Moises.
45.
Okay, who said that?
Betul.
2 again. So 45, which is pi over 4, and this would be the 0 asymptote, and this would be at a pi over 2 asymptote. If I go the other way to get a second picture, this middle would be a negative pi over 4, and this would be a negative pi over 2. Now, normally I'm real lazy, and I just draw it falling or rising. I just looked at it. Did you guys look at it too?
Falling.
Who said that?
Raj.
Raj, it's falling. So let's go ahead and be nice and try to find these middle, oh, I just erased. Find these middle numbers here so I can see how high does that point go, because it is going to fall, okay? So half of pi over 4 is pi over 8. I just doubled the bottom number because it subtracted from 0. The middle here is a little harder. You got to take pi over 4 plus pi over 2, and then you got to divide that by 2. Well, pi over 4, I'll do a common denominator, plus 2 pi over 4 over 2 is 2 pi over 4 divided by 2, which means 2 pi over 8, which means pi over, can't be pi over 4. I messed up then, didn't I? Because it can't be the same pi over 4, because I went pi over 4 plus pi over 2. So it can't be pi over 4 again. So what did I do wrong? Anybody? If you find my mistake, you get double points. If you make me do it all over again, then nobody gets points. Nobody. Okay, I do it all over again. Wait, who's talking?
Raj.
Raj, what?
You didn't add the pi and the 2 pi. You left it as 2 pi instead of 3 pi.
Okay, that probably is it. So it was 3 pi over 4
Yes,
divided by 2?
Yes.
That makes a lot of sense. Raj, see? Double. You got to tell me that though, Raj. That's double. 3 pi over 4, that gives you 3 pi over 8. So that one's 3 pi over 8. I think yesterday I was just tired. I was too lazy. And oh, that makes sense. Watch this. From 0. 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. 4 pi over 8 is pi over 2. Yeah. Good job, Raj. So I'm going to go, I need to plug in these two numbers. That's kind of harder though. It might even be just as easy to pick up your calculator and tell me what 1/3 cotangent of 2 times pi over 8 is. Now let me show you how to do this in a calculator because, again, it's one of those things that we don't think about. So let me show you. I'm going to show you this once. I wanted, what did I, make sure, always check your calculator that you're in Radian mode. See, I'm in Radian up here next to the word float. That's float, not nothing. Where's radians at? Oh, down here. The angle is in radians versus degrees. You can't see. There's degrees, there's radians on mine. So we're always using radians for the most part. I always think in degrees though. Like when I try to speak Spanish, I'm thinking in English. So what was the number in front?
1/3.
1/3. Okay, so 1 divided by 3. I want to do cotangent, but I don't have a cotangent button. So I do parenthesis 1 divided by the tangent is the same thing as cotangent. And we had a, what was the number? The B was 2 again?
Yes.
It again? Was
Yes,
B
it was 2
It
times
was.
pi
2.
over 8.
Oh, I'm typing in pi over 8. Okay, thank you then. See, I forgot what I was doing. Pi over 8. Okay, and so that'll give me that one number. I don't have to do the other because I'll show you why. Wait, I didn't come out right.
It's because it's 2 times pi over 8.
Oh.
Yes.
Oh, it was 2 times pi over 8?
Yes.
So that would be a 2 in here. Let's see if it works. 1/3. 0.3 is forever is 1/3. Oh, yeah, you know why? It's being stretched or compressed. It's getting fatter. Remember I said it's going to be fat? So here in the middle at pi over 8, it really went up a third. So if here's 1, it only goes up here instead. And the other one will be the opposite direction. It'll be down here. So it'll be 1/3 down. And you can label those points 1/3. And then the other one would have been, you could put 1/3 there, negative 1/3 there. All right, here goes. Yesterday I was real lazy though. So here goes. Oh no, why did I put it there for? The center is here. And I don't know if I can even do it. I'm just not a good artist. Close enough. Not bad, is it? Not too bad. For me, I should get an Academy Award or something, an Emmy. All right. Do I want to play around anymore? Not really, because the difference with this number, now this is just a regular tangent shifted up 2. And I'll be honest with you, if I shift up 2, all I'm doing is moving this line up here, up 2. So why don't I just make it simple for myself and just call that line, call that a 2. And that means your 0 is down here. Who cares? So then you do the same thing. I don't even care about the 2 anymore. I just need a tangent graph. Oh yeah, tangent graph. Asymptote. Instead of 0, 0, it's going to be 0, 2. 0, 2 will be the center. And it's still, it was a pi. This distance is pi. So that's still a pi over 2. This is still a negative pi over 2. And tangent rises or falls? Rises, doesn't it?
Yes.
So in the middle of pi over 2 is pi over 4. That goes up to 1 right here. Oh, well, it's not really a 1. It goes up 1, but remember, you're really at a 2, so that really went up to a 3, if you think about it. And then in the middle of this one, it goes down to the negative 1, which really is not a negative 1. It's really a negative, no, it's really a 0. That's where the 0 went. Yeah, here it is. You just take that off, put 0 right here. So yeah, it gets kind of crazy. What do those points mean? You know, if you want to label them all, wonderful. Here goes. Climb, 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 go over, go through that point. There you go. Beautiful graph. Again, I'm not going to make you do a whole bunch of these. The only difference here, it flips the cotangent, therefore it looks like it's a tangent, and it's shifting to the right pi over 4. So what you're having to do is what used to be 0 is now pi over 4. And so it was a cotangent graph. So that's an asymptote here. And this is an asymptote here. And cotangent usually falls, but because there's a negative in front, I think it rises as well. You could find the middle. There's no b. B is a 1. So pi, period, is pi divided by b. From here to here is a distance of pi. To get the whole picture. The whole picture looks like this. Because it's an upside down cotangent. Okay. So I just got to add pi to pi over 4. So that's 4 pi over 4 plus, that's 5 pi over 4. And then if you want more points, you try to find those values. What are those values, you know, and where is it at? Remember, this is a negative 2. That's enough. I'm not going to do any more. You play with the couple in my math lab, and I'll be happy. Okay. Let's move on to 6, secants and cosecant. The reason this is more fun is because it uses everything that you already know. Here's what's happening. We're graphing a secant. I'm going to show you something. That is a picture of secant. If I put a dot here and realize this is half of this part, put a dot here and put a dot here and put a dot here and pretend that one's finished up, put a dot here. Watch what happens when I connect the dots. with a nice pretty curve. What kind of graph does it look like in blue, starting at the 0 and ending at 2 pi? What is that a picture of?
A cosine graph.
Who said that?
And
And again, this is the third time, maybe even fourth. It's a cosine graph. Good job, Ann. So I think of y equals cosine of x. And if you know how to graph the cosine, I'm not going to go into all the details again because you should be a pro at it. It's not shifting. It's not going up or down. There's no b is equal to a 1. So it's 0 to 2 pi. My secret was divide it up into 4 quadrants, 1, 2, 3, and then say half of 2 pi is pi. Half of 0 to pi is pi over 2. Half of pi to 2 pi was 3 pi over 2. I kind of have it memorized now. The height went up to a 1, went down to a -1 because the amplitude is a 1. Remember, the b is a 1, the amplitude's a 1. So to do a cosine graph, I start here, 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 and here. Yes, no? So I'm going to do it real light. Starts here, here, here. Now, that's cosine. I don't want cosine. So let me go and finish up this curve, doing it again with like another side. Okay. And here's secant. Here's for the $100. To graph the secant, I just find all the max or mins. Find all the x-intercepts. Let me put that in a darker. I need all the x-intercepts. I need all the max and mins. Everywhere you see an x-intercept, where it crosses the midline, the midline here is y equals to 0. It could be something else. What we do here, we put an asymptote here. Every place where it crossed the midline, put an asymptote, because secants have asymptotes because it's 1 over cosine. Cosine cannot be 0. So this is where cosine is 0. And 1 over cosine of x is secant of x. Cosine cannot be 0. So I have asymptotes here. What do you think goes in between the asymptotes? The curve. Ooh, I want black. The u's, or the upside down u's. Piece of cake. And so if you want to hide the evidence that you cheated and used the cosine graph, you can erase everything that gave you that secret. Let's see. I'll erase this and erase that. And then boom, boom, boom. Oh, look at that. Nobody will ever know that I cheated. Now, you do have to have these numbers labeled where these asymptotes were and stuff like that. So when you do the graph, you do need to know what this x is, and this x is, and this x. That's where the asymptotes are. So you need at least a couple in there. Okay. I would say if you just did the x's and the y's in this area, or not that, that's too far. If you just did it like those three, you're good to go. Okay. And he does a table to find out what all the y's will be. But I'm telling you, I'm not plugging into secant. No way. With cosecant. What's the reciprocal of cosecant? One over sine. So sine cannot be 0. So you know what I start with? I start with the sine curve. Y equals sine of x. And remember, we have our midline. And since there's a 1 here and a 1 here and a plus 0, it doesn't, that's going to be a 0. And so I have a line here and a line here. That goes 0 to 2 pi. It goes up as high as a 1, goes as low as a -1. Divide that up into 4, just like I did before. And remember what sine curve did. Sine curve was here, goes up to here, comes down to the middle, comes down to the bottom. There's my one graph of sine. You want to make it special, then go ahead and make another part of sine going that way. Make another part going up that way. It just gives you a little more graphs. Since sine cannot be 0, then there is an asymptote at 0. There's an asymptote at pi, because that was in the middle. There's an asymptote at 2 pi. And every multiple of pi, basically, 0, 1 pi, 2 pi, this would be 3 pi. No, I'm sorry, this would be 3 pi. Asymptote. Why is it processing? I didn't do that. So you label where those asymptotes are. Then right here, this was pi over 2. That gets a point. This was 3 pi over 2. That gets a point at -1. So it's pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2 gets a point. And then I just go to all those blue points and I graph my u here. I graph a u here. I graph a u here. Technically, I have another one here. And that's what you're making right here, see? The same picture. Everything's labeled in nice and pretty though. Okay? And it's nice to know those heights. They're all 1. All the heights are 1 for all those. That makes sense? Anybody? Anybody want to? I'm going to look at my screen here on the desktop and try to find your pictures with among it. I got to open it up. And any thumbs up that you understand what I'm doing? Anybody? Let's see. Not very many people. Some of you didn't sign in. Me. I got 1. I can only see a couple pictures at a time. Anybody else that I didn't call on? Okay. Well, all right. So that's your cosecant, your secant. Oh, well, yeah, I was supposed to do cosecant. I did cosecant. Cosecant uses the sine curve. So if you know all the values of this sine curve, if you know what this point is, and you know what this point is, and that point is, and that point is, and that point is, then you have all the numbers you need for cosecant. You have everything you need. You just need to change all these dots that are intercepts, you have to change those to asymptotes. That's all. And then this dot's where the u's go. U's go. See that? It's not that bad. It's not that bad. And in reality, guys, I won't make you erase anything. You could just say that, well, you know what the book said to do is do this when you, like I'm gonna do a cosine now. If I do a cosine, do your cosine with very lightly. Whatever it is, do it lightly, like it's a secret. And then go ahead and do your asymptotes. That was going to be where here. Then you're going to have that. And then you have that one. And sometimes some books actually, that's what they show you for cosecant. They only show you this. The one going out this way, the one coming this way, because they don't finish the worth of cosecant. But you can do more if you want to. Let's try. How much time do I got? I got time to do a couple. Yes, I do. Plenty of time to do what I need you. I don't need you to be a genius at this, because this stuff, if I was to ask my calculus students, how many of them right now could graph this one right here, which should be a piece of cake? I don't think they'll remember, because they only had it one time with me. If they didn't have me in pre-cal, then they probably didn't even get it. In the regular pre-cal, I don't think those teachers do it at all. So I'm going to do a secant graph. So that means I'm thinking cosine. I'm thinking y is 2 cosine of a half x. So it doesn't shift up or down. The amplitude changed to 2, and the b is a half, meaning my period of that cosine curve is 2 pi over 1/2, which means 4 pi. So I'm going to graph on here a cosine graph. It's not shifted left or right. So it starts here and it'll end in a distance of 4 pi. Okay. It goes from 0 to 2. I'll label that. I'll label that. And I'm going to divide this into my 4 equal pieces. And I realize that my cosine starts here, goes down to the middle, goes back.
Sorry, I'm having trouble hearing you.
Oh, okay. Sorry, Siri. So I'll do it in light, just to hide the evidence. There's my cosine. Just to be nice, I might make one more drop down. Maybe I'll make one more drop down just to make a 4 picture. Everywhere where there's an intercept, I'll put my asymptote. Everywhere I have a max or min, that one's wrong. Why did what? Oh, I put a 0 here. That doesn't even exist. I didn't think that looked right when I did it. That was a point I needed to know how far it's going, but it's not part of my, okay, so there should not be an asymptote here. The asymptote would be here. Okay, so at that mountaintop, I graph that. At the peak, I graph that. And it would be nice to put some of those numbers. You know I was going from 0 to 4 pi. So that must mean this was 1 pi, 2 pi, 3 pi. And this is a 1 up here. And this was it was a 2 up here. This was a -2 down here. So as long as you put those there, like this is 2, and this was a -2, and this was a pi, then I know what you're doing. Those are my asymptotes. So that's enough picture. That's enough picture to make me really happy. How about a cosecant graph that has a phase shift? It goes to the right, pi over 2. I'm going to think this, y equals 3/2 sine of x minus pi over 2. Okay, so b is a 1, so period is 2 pi, but it shifts right pi over 2. So what, and it doesn't go up or down. Okay, it doesn't go down, so this is still 0. This now is pi over 2, because it shifted to the right. 0 is over here. That's 0. So I'm going to go from pi over 2 and say, well, it typically will end in 2 pi, right? It'll end over here. So what is that number? Pi over 2 plus 2 pi is how much? Isn't it 5 pi over 2 if I did it right? Tell me if I'm wrong. And then from this pi over 2 in the middle, I have to add those two together. Pi over 2 plus 5 pi over 2 is 6 pi over 2. Divide that by 2 to get this middle here. That turns into 6 pi over 4. Stop me if I mess up, reducing it to 3 pi over 2. So this is 3 pi over 2. The middle between this pi over 2 and 3 pi over 2, what's in the middle of 1 and 3? Well, you don't know it. We got to do the math. That adds up to 4 pi over 2 divided by 2. That's 4 pi over 4. I think it's a pi. Because that was, each of these is a half, it's going to a half is what's happening. And so this must be between 3 pi and 5 pi over 2. That's 8 pi over 2. Cut it in half, 8 pi over 4. 8 pi over 4 is how many? 2 pi. Sine curve starts up at the top. The top in this problem is 3/2 or 1.5. The bottom is negative 1.5. Sine starts here, goes up to here, goes down to here, comes down to here, goes up to here, and I'll do it in a light color. And if I'm nice, if they treat me right, I'll go ahead and go down to a, let's see, where would it going to go? It's going to go left pi. I'm not sure. I'll just play with this one. I'm too lazy to think. This has to be an asymptote. This has to be an asymptote. This has to be an asymptote. Here's all I need. Boom. Let me do a color. If you understand everything that I have done today, you know more about tangents, cotangents, secants, and cosecants than probably 99% of the population. And I'm talking about even population that have become engineers, because we all were taught this stuff, I'll be honest with you, but it doesn't stick because we don't use it very often. Boo-hoo, I'm so sad. Not. You can live without secant graphs in your life. Let's see. Let me see, any thumbs up right now that you're feeling okay? Nothing on the first page of pictures. Oh, I got one. And figures and figures. That's Sophia again. Let me go to the next page. Keep going. Do it again if it goes off. Oh, I got more over there. Got a lot more coming in. Let me go back to the other page because I don't have one. I've got like, yeah, I think a lot of you are getting it. So it isn't as bad as it seems. Now, are you a better drawer than me? Probably. Probably. So do it. I'm not, you're not going to do that many. Matter of fact, I don't think I'm going to give you a quiz having to do it other than how they do it on my math lab. These just want you to write the equation. I'm not that excited about it. It's hard, but here's what I'll do. I didn't get to do this for A day. This looks to me like if I connect this dot with this dot, I don't have enough picture. So it's kind of hard to see what it could have been. Do you think it's a secant or a cosecant? Here's 0. It looks like it could have come up to here. Oh, another asymptote right here. Another asymptote right here. Oh, what did I just graph? What kind of curve, sine or cosine?
Sine.
Sine curve. And so it started at 0. The reciprocal is cosecant. I just graphed a cosecant. And how high did the sine go? 1. How low did the sine go? -1. So there's a 1. And it finished in 2 pi, so B is a 1. So let's see, does it shift left? It didn't. I just graphed the secant, the cosecant of x. That's all that was. Now this one is trickier. This had to be an x-intercept. That had to be an x-intercept. That has to be an x-intercept because it's something that was 0. The picture goes up to here, comes down to here. And what did it do? How did I get to here? Anybody want to help me out? I'm not an artist. What curve is there? What curve could be there? Anybody?
A cosine graph?
Cosine graph. You're saying it starts up here, comes down. And how do I get to here though? Oh, I'm not sure how it gets to there. I'm actually clueless. Yeah, it looks like it could be a cosine graph starting at 0, starting at the top. Yeah, that does look like it. But then what about here? Oh, it finished the cos. Maybe no, I don't know what it did. To be honest with you, I don't know what it did. I think it is a secant, but I think it finished it up in 0 to pi over 2. Then there's another adding pi into it. So it is a pi. So the amplitudes, I mean, the period is still pi.
So you can get
maybe.
so you can get to that point if you extend it a little bit more on the right side.
Okay, tell me again. Talk to me slow. I'm old and feeble. Talk to me slow. Okay, tell me do what now?
If you start from the first point
Yes.
and then bring it down to the right.
And I was just thinking of something. Isn't it true that my sinusoid would have to be in the middle of this thing? Oh, that might help a little bit, maybe. I'm putting dots down here. The dots don't go here. The dots go here and here. Because it has to be the middle of the sine, whatever, sine curve or cosine curve. So that has to be up here. I was looking at it down here. That's wrong. Okay, let me see. I go through here, and I come down to here, like that. Yeah, I think that'll work. It is a cosine curve, because that would go up more. Whoever said cosine is right. It's starting up on high. It's not starting here, so it's a cosine. This has to be a secant. And let's see, how high does it go? Does he give me any label on this? I have to erase it. I can't see if I wrote over it. Does he give me a height of that? He didn't give me a height. Oh, yes, he did. That's a 1. That must be a 2. So he shifted up 1 for the midline of my cosine curve. So it has to be a +1 out here, or a 1 plus, however you want to do it. It finished it up in pi, so there's b is a 1. So it's just 1 plus secant of x, I think. I think so. From 0, oh no, wait, but the picture went from here to here to here. It's not finished yet. Cosine has to go up a little more. Okay, so how long did it take? It took 3 pi over 2, 1 pi over 2. I think it goes to 4 pi over 2. It is 4 pi over 2, which is 2 pi. So it's just there's just a 1 here. It's just, that's what it is. It's 1 plus secant of x. Harder than I thought it'd be. Thanks, Anne. Because you helped me realize that to get the picture you were saying, I had to realize that the middle of the graph had to be in there. Basically, my point is this: if you can try to identify what sine or cosine, then at least you get credit because at least you know it was secant. Then if you realize that that midline went up 1 instead of here at 0, then it helps. Stressful. And that takes me to almost the end. I don't want to bore you to death. There is one My Math Lab will be up probably by lunchtime, and it'll have a few tangents and cotangents and a few of these. I didn't go all the way. I did not make you identify graphs, okay? Why? It's not worth our time. Let's just go do what the college said. I taught it, and you've been exposed to it. If you want to know more about secants and cosecants, go for it. Do all you can on your own. You can probably find a good YouTube video of a person who loves doing cotangent graphs. They're an expert at cotangent graphs. All right, I see 9 in the chat. let me close this. I can get the whole screen up to see, make sure that most of you were here. Okay, 1, 2, 3, 4, 5, 6, 7.